Let's learn how to use FreeRTOS with STM32 F446 Nucleo board. In this lesson, we will learn how to create a task, how to delete the task, how to deal with a scheduler, and then how to work with the task priorities. Thanks to Altium Software for sponsoring this video. The cloud-based Altium 365 offers seamless collaboration between engineers along with version control capability. Altium is all-in-one platform for all the needs of PCB design. Feel free to check my Altium tutorial series to learn more. You can download free trial with the link given in a video description. Also, you can sign up with the link altium.com/yt/binary update. So let's create a fresh new project. Go to file in a top left corner, click on new and select STM32 project. Now in a target selection, we have to select STM32 F446RE. That's basically our microcontroller is. And then we have to select STM32 F446RE Nucleo board. So click on next. Then it will present us to give the name for the project. I would like to call this project as FreeRTOS. Okay, and I'm happy with all the default setting here. So click on finish. So this basically configure the project for us. You can see in the left pan, we will have a project with the name FreeRTOS. It takes a couple of minutes to configure the project for us. So please wait and watch. Once the configuration is done, you can see the project is created and we will be presented with pinout and configuration. You can see the microcontroller chip here, pin plannings. So if I change anything into the pinout and configuration, you can see the changes will be reflected here. So the first thing first, we have to go to system core and then we have to select sys. And under sys, you can see under debug option in the drop down, we have to select trace asynchronous because we will be using a debugging capability on STM32 microcontroller. And then the time based source we have to select as a timer 6 because we should not use SysTick timer because that will be reserved for FreeRTOS. So we have to select any timer except SysTick, and I'm happy to go with a timer 6. Okay, TIM6 I will select, and that's absolutely fine. You can see some pins are selected because we have chosen this trace asynchronous, so that's basically select the debugging ports for us. Okay, so that's okay for now. So once we are done with system core setting, then we will click on middleware, and under middleware we have this FreeRTOS. So click on FreeRTOS, and once we click on FreeRTOS, you can see interface option in a drop down, it's disabled. So if I click the drop down, then I have to select CMSys version 2 because I'm using CMSys APIs, CMSys RTOS. That's basically uses under the hood FreeRTOS APIs. So if I make a little bit of space for you to see, you can see the configuration shows up here. And by default, you can see if I scroll down a little bit config parameters, you can see the total heap size is 15 kilobytes. That's basically 15,000 bytes. And the memory management scheme will be used heap 4. You don't really need to know all those technical things at the moment. All what you should know is we are creating a task under the microcontroller STM32, and we will be doing a multitasking by running this task parallelly. Okay, the task is basically perform the functions. So let's go to task options here, and under the task you see we already have a default task here. So double click on default task, and then the task name I want to change it as a task 1. So that's basically the name of my task. And then for the entry function name, I want to call this as a start task 1. So the first task that we are creating, FreeRTOS task 1, has a stack size of 128 words, and the entry function is a start task 1. Okay, so click on OK, and now you see if I take you to the task and queues again, you can see now the default task will be renamed as a task 1. So I need to create one more task. So click on add again, and now for the second task, I would call this task as a task 2. I will name it as a task 2, and then I will call entry function as a start task 2. Okay, I'm happy with it. And again, the stack size is 128 words. So click on OK, and now we have a 2 task. And if you look closer details about it, you can able to see lot more details here, but it's not really important for us. Okay, like you can expand and then you can see as much information as you want. And you can see we have the priority options as well, right? Of course, you have to create a little bit of space in order to see what's been given, and you can see the task 1 has a OS priority normal and task 2 has a OS priority low. So task 2 has a lower priority and task 1 is having a normal priority. So the task 1 will execute first and task 2 will execute later. Okay, that's all what it means. So now either you can click on the top menu bar, this generate device configuration tool for code generation. So this icon you can click, otherwise you can just click on save. I prefer to just click on save button. So when you click on save, it says, do you want to generate a code? Yes. So click on yes and it will generate the code for us. Again, it asks us, do you want to switch into C and C++ perspective? I would click on yes again because I want to go into the C and C++ perspective. One strange warning you might get is code generation, and this is basically has to do with C standard libraries, and we are not doing anything special here, so we are okay with, do you still want to generate the code? I just say yes, that's absolutely fine for me. And this takes a couple of seconds to configure, and then you will see the project setup happens, and then we will be presented main.c file. And under main.c file, if you scroll down, you can see we have a 2 tasks. So here you see the definition, task definition for the task 1, and this is for the task 2, the definition for the task 2. And if I can take you further down into the code, you can able to see that we have this OS kernel initialize. So that's basically initialize the scheduler. And if I can take you even further, you can see creation of task. So task 1 handle and task 2 handle for both task. And then you see we have this OS kernel starts. That's basically a scheduler. So scheduler basically control how the task will execute. So this is a scheduler. Once the scheduler get called, then it will control how the task will perform, how the task will execute. Now if I take you further, you can see the super loop. This while loop is completely empty because this code uses an operating system, FreeRTOS as an operating system, or you can say CMSIS RTOS. So I can take you further and you can see there is this start task 1 and here is start task 2 function. Okay, so whatever we want this task 1 has to do, we will write into this for loop, and whatever the function that activity that the task 2 has to perform has to be written into this for loop. Okay, under the task 2 start task 2 function. Okay, so that's basically the task. Now I want to write a code where I will print task 1 text when the task 1 execute, and then it will print task 2 when the task 2 executes. Okay, that's basically my goal and objective, and it will parallelly do a multitasking, and as the both tasks execute, the task 1 and task 2 will be printed on our data console, on the debugging console. Okay, so to do this I need to use printf style debugging because that's the easiest to go with. And to add the support for printf, we have to expand this core, and then we have to expand the src source folder. And now we are into this main.c file. So if I double click, you can see we are still there, but we have to add some piece of code under syscall.c function. So double click on syscall.c file, and under the syscall.c file, in order to add support for printf function, we have to add few lines of code. And let me just paste the code that I copied. So let me just paste it here, and this is basically a piece of code where we are creating this ITM sendchar function. Okay, and this function basically uses the port 0 for debugging, and it uses ITM feature from the Cortex microcontroller architecture, ARM microcontroller architecture, which helps us to use the debugging capability, and we can also use the printf style debugging. So to copy this piece of code, you can either download this entire project file, or you can find it in the attachment or in the description section somewhere. This syscall.c file can be accessible. I would make sure that you would get this piece of code, and then you can add this piece of code here. That's basically allow us to use this ITM sendchar function. One more change we have to do into this syscall.c file. If we take you further, you can see there is a weak function. So there's a weak write function, and under this function we have to add this ITM underscore sendchar function, and under this we have to pass this pointer. Okay, so let me just copy and paste it here, and this one line of code we have to add into this file, syscall.c file, and this line is no longer important for us because we are not using it. Okay, so we have earlier added this piece of code where we made this function. Okay, this is the function where we have defined that function, And now here we are using this ITM sendchar function that basically allow us to use the printf style debugging. So save the file, Control S, and then let's go to main.c file. Now since printf is the function which is come from C standard libraries, we have to add few include statement here. Now under the private include user code begin include, I will have to add one more line of code. So hash include, and then I would just say stdio.h. That's a C standard header, standard input output. That's basically allow us to use the printf function into our STM32 microcontroller project. Otherwise, if I straight away use this printf function to print a text on a debugging, then it will throw us an error that the function couldn't recognize. So once we added this one line of code as an include statement, then we go further into the code, and then we will look inside the start task 1 function, and here under the for loop we have to add the line of code, let's say printf, and in a printf function in a double quote I will have to type the text task 1 that I want to print, and then I will add new line character, right? So this basically whenever the task 1 executes, start task 1 entry function get invoked and it will print task 1. So this is the piece of code that we have to add. And then OS delay function will take a parameter. I would put 1000 milliseconds. So that basically what does this means? This means that whenever the printf function will get execute, whenever the task 1 get called, then it will print task 1 and then it block the task 1 for 1 second. So this OS delay function block the task for 1000 milliseconds. That's basically a 1 second. Similarly, let's go to start task 2 function, and under the for loop I will have to add this one line of code which is basically to print the text task 2, and again to add new line character, and then once the task 2 execute we have to block the task 2 for 1 second again. So it's a 1000 milliseconds. That's basically a 1 second. So this is the code that we have to add. Now we can save the file before we upload, or maybe before we build the code. So you see in top left menu bar there's this build hammer. So click on this hammer that basically build the code, and we will have to check whether we have any errors or warnings. So you see we have a 0 error and 0 warning. So now to see the output that whenever we upload the code onto the chip, then the parallel execution of task happens, we will be using a debugger. So we have to click on this bug icon on the top menu bar. So click on this bug icon, and then the debug configuration shows up here. We have to select this debugger option here, and then you see for debugging we have to check this box ST-Link, because we are using ST-Link debugger which is on STM32 F446 Nucleo board. And then if you click on scan button here, then it will read the serial number that ensure that your STM32 Nucleo board is connected to your laptop. And then going further, you see as we are using a debugging capability which is a serial wire viewer, we have to check this enable box. So that's basically enable the serial wire view for us, so we can use the serial wire viewer data console to see the output from the printf statement. So click on apply and click on OK. So this is the configuration that we did for debugging. Now it will take a couple of seconds before it takes us to the debug perspective. So you can see confirm the perspective switch. So it will take us to the debugging window. Okay, so click on switch. So it will switch from C++ to the debugging. And now we are into the debug perspective. You can see it looks a little bit different. Now we have to go to Windows. Then we have to click on show view. And then we will go SWV because we are using serial wire viewer to see the debug output. Then we will have to select SWV ITM data console. So click on this SWV ITM data console, and then you see here down below we have this special tab SWV ITM data console. Okay, so we have to configure this debug setting again to use this serial wire viewer. So we have this configure trace option here. So click on this option, and since for debugging we are using port 0, so we check this first checkbox. So that's basically port 0 for enabling the port 0 for debugging, and then click on OK. And then we have this red button here that's basically start to record the debug trace. So click on start trace. Okay, and then you see in the top left menu bar we have this resume button. So when we click on this resume button, then the task start executing. I can make this little bit bigger so you can see the task 1 execute first. That's why I can click this remove all collected SWV data, and now you can see the task 1 execute, then task 2 execute, and always the task 1 execute, then task 2 execute. Okay, let me just clear again for you, and I can just click on this suspend, and now you can see it says you're opening larger file or something. Do you want scalability setting? I would just say no, I'm okay with it. Now you can see we have first the task 1 get printed. That's what we said. When the task 1 execute, the task 1 text will be printed. When the task 2 will execute, then the text task 2 will be printed. Okay, let me just resume again, and now you see the parallel task execution starts. So this is basically what proves the parallel code execution starts, right? So let me just terminate the task. This is how you can create the FreeRTOS task and run them parallelly with the multitasking. Now let me take you back to our main.c file, and I want to show you something. So when you saw the output earlier, you see the task 1 execute first and then the task 2 execute. That's why the task 1 get printed first and then the task 2 text printed second. That is because we set the priority. Now I want to talk about the task priorities. Now what if you want to run the task 2 first? So the task 2 will be printed first and then task 1 will be printed second, because task 2 will execute first. So to change the priorities, either you can change into the code here, or you have to go to this freertos.ioc file. So there are two ways you can do that. I would rather take you to freertos.ioc file. Okay, and here under the task and queues, you see we have the priority. So the task 1 has a OS priority normal, and the task 2 has a lower priority. So what if I double click this? Okay, and for priority for task 1 in the drop down, let me just select the lower priority for task 1. Okay, so in the drop down somewhere on the top you have this OS priority low. So let me select OS priority low for task 1. Okay, and then click on OK. So now you see the task 1 has a lower priority, and for task 2 I double click to open, means to edit the task 2 settings. The priority I want to make it as a normal. Okay, so OS priority normal. Okay, so OS priority normal. So select OS priority normal and then click on OK. Now I reverse the priority. Now I have given the higher priority for task 2, means OS priority normal is the highest priority, and task 1 has a lower priority because I put the OS priority low for the task 1. Now what happens is, with this changes, our task 2 will execute first. So the task 2 text will be printed first and task 1 text will be printed second. That's basically proves the task execution, how you can control which task to execute first. This is an awesome feature using an operating system like FreeRTOS into the microcontroller project, STM32 project. We can possibly do that, and if we don't use any operating system, then we can't able to do this higher level stuff. It basically gives you more control over your code execution. Now once we're done with our settings, then we have to make sure that we click this button, device configuration, code generation or something. So click on this code generation option here, and then it says the code will be modified or something, perspective will be switched. So just click on yes. Okay, and then say yes, and then we will observe whether some changes have happened or not. Okay, so the changes has been reflected here. Now look at this, the task 1. So this is for the task 1 handle, and now you see the task 1 has a OS priority low. That's exactly what we set up into our IOC file. And now for task 2 handle, we have the OS priority normal. Earlier we have had the task 2 with a lower priority and the task 1 has a normal priority. With this changes, let's build the code. Okay, click on this hammer on the top left corner to see whether we have any error or something. Okay, so there are 0 error and 0 warning. Now we can click on this bug icon to get into the debug window, debug perspective. So click on debug icon here, bug icon, and it will again take few seconds, and it will give us this pop-up to click on switch. So click on switch, so it will take us to the debug perspective. And now we will select, either we will click on this SWV ITM data console. If you cannot find it, always remember, go to Windows, show view, and then SWV, and then you can click on SWV ITM data console. Okay, I hope you remember from the previous discussion. And then we have to click on this red button to start capturing the debug trace to see the output. So click on start trace. And then let me click on this resume button to resume the debugging. So click on resume. And now you see, let me just suspend for you to see. Now you see, this time when I started my debug session, the task 2 will be printed first, because the task 2 execute first and then the task 1 execute later, right? So that's how it works. You can change, you can control which task to execute first and which task to execute second, depending on how important the task is, how important the functionality has to be inside the code. Now let me just click on resume again, and now you can see the task 2 execute first and task 1 execute later. So this is how we can create a task, and we can also change the priority of the task. Okay, so let me just terminate the session here. Okay, and it will take us back to C++ perspective. I go to main.c file here, and again I will go to FreeRTOS IOC file again, and I double click on the task 1 here under task and queues, and I will make this as a normal priority for task 1, because I want to show you something important here. So the task 1 will have now a normal priority, and for task 2 we will again set up the OS priority low, which we have done it before. Okay, and because we now changed the task priorities, I want to show you now the concept how you can delete the task. Okay, so how to create the task, how to delete the task. So let's save the file, save the changes, and click on this. Even if you don't save, if you just click on this code generation button on the menu bar, click on yes, and click on yes again for that warning, and our changes will be reflected. Okay, so now let's see if the changes are reflected. Now you see the task 1 handle has a normal priority and task 2 has a OS priority low. So that means the task 1 will execute and then the task 2 will execute. I don't have to show you again by running that. I hope you revisit and just confirm. Now I want to show you what if you want to delete the task 2. Okay, so let me just show you. Let's just get into the start task 1, and there is a start task 2. So I think it's good if we don't delete the task 2. Rather, we will write the code under task 2, okay, wherein we will delete the task 1. So task 1 will only execute once, because the task 1 has the highest priority. So it has the OS priority normal, so it will execute for once. And then the task 2 will execute, wherein it will print the task 2, okay, on the debug window. And after printing the task 2, we want to delete the task 1. So basically only the task 2 will keep on executing and task 1 only execute once. Okay, that's what I want to show you, that we will be using task 2. We will be using task 2. So this is the piece of code for task 2. And under this task 2, we will delete the task 1. So it's possible in the FreeRTOS that you can delete the other task from other task. Okay, that means you can delete one task from the another task. That is possible. Let me just show you. So here, after printing task 2 under the task 2, and then it also take once, it will block the task 2 for 1 second, and after blocking the task for 1 second, task 2 for 1 second, then we have to call the API OS thread, THREAD thread, and control space, And then we have to terminate. I think I should have to type something more. Okay, so OS thread terminate is the API that we are using, and this basically takes the parameter as the task handle that you want to terminate. So basically OS thread terminate API will delete this function or API, whatever you call, basically takes the parameter of the task that you want to delete. So here we want to delete the task 1 from the task 2, so we have to pass the task 1 handle here. Okay, so we have to just say task 1 handle. Okay, and now what it does is, it's basically at this line of code, when the task 2 execute, it will delete is basically a terminate. So OS thread terminate basically called vtask delete function, which is basically an API from FreeRTOS that will delete the task. So, and the task that we want to delete is task 1 handle. Okay, so that's basically what it is. Now let's save the project, Control S, and then click on this hammer icon on the top left corner to build the code and see if we have any error or warnings or something like that. Okay, so you see we have a 0 error and 0 warning. Now let's click on this bug icon to enter into the debug session. So click on this bug icon. Okay, so I accidentally double clicked it, so that's why this pop-up shows up. But now we are already into the debug session. Okay, so as I said, we should select SWV ITM data console, and we have this port 0. So to start capturing the debug trace, we will have to click on this red button, start trace, and then we will click on this resume button on the top menu bar. That's basically resume the task, and once the task execute, you can see it prints the task 1 and the task 1 and task 2, because we set up the priorities, and then we see the task 1 get printed once, and then we have only task 2 is executing. That's why we have only task 2 get printed, because the task 1 is deleted, it only execute once, and because it has the highest priority. Let me just delete all the content under this data console, and now you see only the task 2 is executing. If I can terminate, or I can just press the reset button on my Nucleo board, you can see the task 1 execute. Again, it execute once again because we put it after delay function, but I think just 2 times the task 1 executes. Basically, logically, if you look at, only the task 1 execute once, and then under the task 2, because it's too fast and do the context switching later, only task 2 exists, because task 1 doesn't exist. We deleted, terminated that task, and now we have only the task 2 executing. Okay, I hope you get my point, how you can create the task. I showed you how to delete the task 1, so now we have only the task 2 executing. It only print the task 2. And as far as the scheduler goes, I also have shown you the scheduler. Let me show you again into the code. So here we have OS kernel start, so that's basically start the scheduler for us. So that's basically control the task 1 and task 2, how to execute the task 1 and task 2. Okay, so that's basically a very important component of a real-time operating system. I hope you have found this video educational and entertaining. If you're trying to solve a problem and learn embedded systems, check out our Embedded System Career Plus course. The link is given in a video description or in a comment section. It's all you need to become a professional embedded developer. Thank you very much for your time, and see you into the next video. Bye bye for now.